Last portion that's important for molecular orbitals. So far, we've only talked about homonuclear diatomic, so the energies are the same in the way they're combining. Now let's talk about heteronuclear diatomic orbital diagrams. The element that's higher in electronegativity has its atomic orbitals lower in energy since it's more stable because of having more pair of electrons. When two atomic orbitals are different, the lower energy atomic orbital makes a greater contribution to the bonding molecular orbitals, and the higher energy atomic orbitals make a greater contribution to the anti-bonding molecular orbital. The best way to understand this is let's look at an example of what's on your worksheet, carbon monoxide. So you have the carbon and the oxygen. Now, energy diagram, would write my atomic orbitals for my carbon and my oxygen. Since my carbon is less electronegative, my atomic orbitals for carbon will be higher in energy. And my oxygen will be a little bit lower in energy. And then the question is, well, how do I make the arrangement of the molecular orbitals? I know that carbon, due to the unpairing of the electrons, has sp orbital mixing, so my sigma 2p is a little bit more unstable. But my oxygen does not have that case. Well, because oxygen is more electronegative and more stable, it contributes to the bonding molecular orbitals. So the symmetry here will be, you have the sigma 2p, 2s, and sigma 2s star. The bonding will be contributed from the more electronegative element and the anti-bonding from the less electronegative element. Then, because oxygen is more electronegative, then sigma 2p forms first, and then the pi 2p. Then you have the anti-bonding pi 2p and sigma 2p star. So you have the bonding that will be contributed from the oxygen, and then you finish the molecule with the carbon. Now, carbon has 4 valence electrons and oxygen has 6, so the molecule should have 10. 2, 4, 6, 8, 10. Now, what if I added CO plus? Right? One of the atoms would have a plus. Which one should take the plus charge? Would it be the more electronegative element or the less electronegative element? It would be the less electronegative element, right? So carbon would lose one of its electrons. What if I had CO minus? Which one would get the minus charge? The less electronegative or the more electronegative? The more electronegative. Oxygen would get the extra electron. So when you construct the orbital diagram for heteronuclear, you look at which one you have that's more electronegative. That is the one that's contributing to the bonding. So there's the arrangement in ascending order of the molecular orbitals that will go and contribute first, since the less electronegative element will contribute more to the anti-bonding orbitals.